The equation's kind of set up for you. If you haven't started number three, start you. Hey, you guys, by the way, when you cross out number six, there's actually an error in the way number six is typed and worded, and I don't think the textbook caught it. And if you get done early, you want to talk about why number six isn't a good question, I'll talk about that with you. All right, when you're ready to do number three, you're going to pick a different planet. I have the equations done for you for the other planets. So just pick one of these planets and one of these equations, and you're going to graph it, and then you'll answer 5 and 7, not number 6. Okay? All I did was change A to get these other planetary equations. And so I took these numbers and divided them by 2, because that's what's required. All I did for you was divide it by 2. And this is the equation you're working with. And I have all of the vertexes for all of these planets, so when you're ready, I can check it for you. So we're just graphing it? You'll graph it and you'll answer. You'll end up comparing your planet to Earth. You'll say which one was higher.
And that's the answer for 3.
Well, it says choose one. I made it one planet. So this is what I did to get these. So for 3, you pick one and write it here.
That is so probably, but I prefer a planet.
Negative 0.06.
Have you ever seen
And the other one is negative 5.06.
Saturn's so far. Like when I think of planet, I think of Mercury.
Identify A,
Oh, we're not supposed to write. Yeah. Yeah. It's just sure.
I've been 2 times.
Negative 43. One 1.833. Here, just write down yeah. Negative 73.07. Like the answer? Negative 73. Plus 80.
80 times 1.5.
146.4.
73.07.
Okay, so we have to regraph the earth.
100.
We have to graph the earth one and graph the Mars one. So I'm gonna
78.33.
graph the Mars one.
Yeah, no, it took me like 20 minutes to get in because I'm not going to find up here. Even though I have a sport.
So this is the x value.
Is that? Sorry, do we have to use decimals if we want to go up and further? Yeah.
2.83 times 0.83.
So we're just doing number 4 now?
1.6.
Multiply that by negative 21.8.
It's a positive 1.83, and then it's easier.
Yeah, I'm just gonna get to it. Let me try.
0.83 times 0.83.
Here, I'm just gonna do 0.83.
And then multiply by negative 21.
I'm gonna check Jupiter.
Negative
Jupiter
15.0.
Jupiter has the largest amount of gravity. More gravity than Earth. If we were on Jupiter, it'd be like sucking down to the Earth right now. I guess you can't call it Earth ground.
More like 6.6.
4 plus 5 plus negative 15.
Jupiter is
40.8.
Alright, the vertex for Jupiter is 0.9, comma 42.5. Did you get 0.9 by chance? Yeah. For Jupiter? Mars is the orange planet up here. Mars goes so high. You're watching it really high. There's the Mars vertex.
Here, I'm gonna try again because I know I got it. Can you say that equation again?
Yeah. Negative 1.83
And then it would be a positive.
It'd be a positive and then be a negative again.
And then times 21,
Just change
and
that.
negative 21.82. Hold on. 1.83.
Second time. And times negative 21.8.
Negative 73.07. I think I probably forgot the subtraction. And negative 214. Point 47. Negative 174.75. And I got 174.75.
Do 80 times 2.83.
226.3.
Okay, so if we want to fit, we're gonna have to.
Oh wait,
200.
yeah, 226. Plus negative is 174.75.
Negative 174.
I just have
I have a backspace button.
oh, that works.
56.65. Can I check the
Maybe
button?
42, I think.
It's kind of near.
Miss, it's supposed to be like even on both sides, right?
Yeah, just a different decimal. Or not decimal.
42.5. Depends how you set
Yeah, we got 40 minutes.
Did you check it?
No.
Them two blue.
I'm gonna use
1.878.
just kind of fix.
Yeah,
I'd say we just
I think it was probably just a check.
just so
That's what we're doing right now.
We got 56.67.
You don't see perfect symmetry with decimals.
I need to be.
Here, let me retry it then, because I deleted it. All right.
I can actually drag it. So I'm doing 3.83.
What is it?
Do you want to know what 3.8 is?
2.8. Yeah. Oh. Yeah, so could you try 0.3? I mean 0.83. Yeah. Okay, thank you.
Okay, so 56. Negative 15.0.
No, ours is a much
Forty-one. Yes. Let's try that last one again. No, not the last problem, like the last one on this like last equation I need, yes. Oh, it's 56.37. No, that wasn't even me, bro. I was typing it in. And don't we have to do 3.83?
Or if you want to go 0 and negative 1, you can. No, the other side 2 and 3.
Negative 320.07.
What did you check on them? Is everybody good?
07.
Just figured you need Mercury on Mars.
306.4.
Okay, do 306.4 plus 5 plus 5 plus negative 320. Yeah.
320.
Yeah. Negative 300.
So, what did we do?
Should be like 214.
Bro, is okay. Let's do it again. Let's do it again because I could have sworn it was like 320.
Ours is 260.
Because those two are canceling out.
Can we do ours?
No, we have to check the other one again. We must have just okay. Let's write it down. Negative 8.67. Just write that one down and we'll redo that. Those first problems. That must have been right, because that's our original. Is that not our vertex? Is it? What's our vertex?
No, the lower A.
Oh. Negative.
No, I'm saying like the lower it is, the less distance.
Negative 73.07.
And then do 8 times negative 1. I've never actually seen any numbers.
Negative 146.4. Wait, so negative 146.4 plus 5 plus
Negative 73.
Negative 214.47.
Okay, so this one.
Yes.
Okay.
Okay.
You guys, you're going to start a lesson in about 8 minutes. Okay, so if you're not done in about 8 minutes, one person will take it home and finish it for homework.
Yes.
Times negative 21.
Negative 320.07.
Okay. Plus
80.
80 times 3.83.
Negative 3.83.
You can get
306.4. Yes.
No, it wouldn't because.
That's fine. Oh,
6.4.
Is 250.
Bro, what could be the math error? Like, we triple checked it, like back to back. Negative 21.
Natural height.
Negative 21. Yeah. 0.82 t to the power 10 plus 80t. I mean plus. Like what is this? Like what are these? Oh, they feel weird. Yeah. I would work at a summer camp. I work on triceps. I want to work on triceps. I love triceps. I need to work on like because it looks embarrassing in comparison to the rest of my body. Do you want to grab it on there? Let me triple check this one.
There's a huge difference.
So you're two units from your rear foot. So 3.8, you're at what?
Negative 8.7.
And we're
We're on Neptune.
What should be the first one is wrong? Oh my god. The first one.
Yeah.
Dang. Dang. What did I? Oh.
No, we had it right. It was 3.8.
It's that negative.
Yeah, it's negative 8. Yeah. Negative 1.8.
I think that's a different point. There we go. Dude, no
You're
way.
right.
We're right. That's crazy. Because the way we were sitting there, we're like, we're so stupid. That's crazy. Do you see that? We got it right, Miss Baldwin.
Yeah, we got it right.
That's crazy. Oh my god. Bruh. And the way we were like, we're so dumb, like, we're getting it wrong. Thank you, Lord.
all right, so Neptune. Oh, this one is just on. Did you get 78? For 1.8.
Yeah.
It's pretty. Oh, you didn't add the 5. Oh, yeah. 73 for 5.
Wait, what was it?
78.
My calculation is 79.9.
5, 6, and 7. I know she said just pick one, but I don't remember which one she said. So that's what we would have to do. Five on which planet is the last name have the next day. You know how many we have to fill in those?
Oh, yeah.
She's literally gonna sign up for her own work. I'll do it.
And then it'll go to higher elementary because it has the least gravity.
If you want to figure out that, some people do it really fast. Like, what are your Y's going? That's actually why are you not going to be okay? Yeah, because the gravity there is
We even checked it on Desmos, and Desmos doesn't even know. No, don't what? Bro, I'm gonna try and move on to number 5, but I want to figure out.
You guys, in about like 3 minutes, I'm going over some really important notes. If you actually don't want to go. Yeah, your planet and Earth. All right, you guys. So it looks like people are finishing up.
Also, I wanted to figure out. Oh my gosh, I wanted to figure out. For number 5, do we have to fill in all of these in order to figure out which one? Okay. Thank you.
All right, so if you're raise your hand if your group is done. Whoa, not many. Sorry about you guys. For everyone who's done, you guys, what did you put for number 7? No, don't rewind. We did not put it. What did you guys put? That's your James.
I'm gonna write. Just kidding. You go ahead. It's in your grade. What? Ma'am, I don't think we can do that.
Could she repeat that?
A lower level of gravity is going to make your balloon fly higher. Or you could say that the other way. A higher gravity means that the balloon doesn't go as high. Like if you did Jupiter, Jupiter's got the largest gravity on here. The balloon only goes up 42 feet. It goes nowhere. But if you did Mercury, only has a gravity of 5. It goes like well over 250. It goes over twice where it would go here if it was launched in Earth. Okay, so the moon has even less gravity than all of these planets. Do you guys know when the last time that a person stepped out on the moon, what year it was around? It was in the 70s. Nobody has stepped out onto the moon since the 70s. And I started thinking about it. Has anybody seen a space shuttle launch from Earth? Maybe in real life, maybe on a video. It takes rocket fuel, engines, fire. If you're near it in real life, you can feel it take off. It's so loud, you wear earplugs, right? Now, if you actually land somewhere like the moon, like we haven't done it for 50 years, it's complicated. How did they leave the moon? Have you thought about that? They got out, got back in. How did they leave? Like, it took so much to launch from Earth. There's no equipment on the moon. How did they leave the moon?
It takes less gravity to hold them back. So
Yeah.
It was easier for them to fly away.
Yes, it was significantly easier because the gravity is so light. So here's a video of how it works. This is actually their launch from the moon in the 70s. There's people in there.
Proceeded, 3, 2, 1, ignition. Turn away, Houston. Vector good.
So cute and little. Like it was so easy to launch off the moon. I'm not saying this is easy, it's rocket science.
Okay, yeah, get back.
But since the gravitational pull was so light, they just needed like a little poop, and then it floated away. So it's kind of like a helium balloon, right? So all of the big equipment that landed, they left the camera there, and then it's probably somebody here from NASA moving the cameras.
It's still like working after 50 years.
No, this is a 50-year-old video.
No, I mean the camera. You were like, oh, like it's still working.
No, he asked me that day who the YouTube
Oh.
Yeah. It was somebody on Earth moving the camera that was there. So there's like, so there is some garbage left over from that on the moon. And then they came back in that little thing. But people are more and more interested in the moon again. I think they're going to try to land there again. I think actually China went and landed. But Elon Musk and Jeff Bezos, are they trying to land people on the moon? They're actually just trying to orbit it or go see it, turn around and come back. They're not trying to let people out and then launch again. And actually, if you watch the footage of this, I just watched it. One of the astronauts that had to walk, like that's the flag he had to walk to. You can like tell he was visibly scared. Like he was like this. And there's the space shuttle, and he just like wanted to go hang on something because he just like was close to floating away.
Do you believe in the man on the moon theory?
Like
you know that photo, the man on the moon. Like there's a photo, and it was like. Yeah, there was like a conspiracy that there was an extraterrestrial.
But they did find fossils of bacteria on Mars, which means that at one point there was a tiny bacteria, which is an organism living on Mars, which is a fossil of an alien. Okay? Not to say an alien is like a species, like a animal or a human, but a bacteria as a living creature, right, on another planet.
Wasn't there like evidence that there was water once on Mars?
Right. They say that Mars is like the most similar planet to us. And then when I was looking at Desmos, I really kind of questioned that because the gravity on Mars, I think it's the orange one, is like so significantly different than the gravity on Earth. But they have found like elements on Mars.
I thought where you were going to see was like the one picture where it's like the flag is like waving and like up in the air. But like when you think about it, wouldn't be waving.
Actually, I watched the video and it's the gravity. I saw it. So like if we put a flag on our ground, the fabric lays flat. And if you watch the astronauts, they put it in and the fabric like lifted and stayed open because it wasn't enough gravity to pull the fabric down. So it's floating from a lack of gravity. So watch the video, it's legit, it looks real. They enhanced the video recently because they used to be black and white. So find the one that's in color. It's cool. Alright, that's all we have time for. We're really gonna move on. So if you're done, put your green paper in the basket. If you're not, one person has to finish it for homework. Or stay after school, I'll do it with you. And then we gotta take some notes.
Does not play. I feel like the statistics page is like, bro.
What about?
We have to compare it to Earth.
Okay. You right?
I think on Khan it just has the L initial.
If I just see your.
Alright, you guys, I'm gonna jump straight into this. I have 11 minutes to show you 6 steps and do one example. Okay? I saw you guys work through these graphs with decimals and all the steps with the vertices. You guys are getting pretty fluent at that. So we're taking a break from graphing and we're gonna actually be plugging in and doing math here. Which for me I'm ready for. I feel like we haven't done enough like straight math yet this year. We've just been talking and moving things around and you already saw my answers. Okay. Okay, chapter 2 about point 3 is about writing an equation. So, if you're given the vertex of a parabola, you don't know anything, but you know the vertex, and you know one other point, you can write an equation. That's all it takes. 2 points and you can write an equation. So if we're thinking about the video on the water balloon launch, if they knew the highest point and where they took off from, they could write their equation, and that's kind of what they were explaining in that video. So the first thing you do is you start with this model, the transformation model, or we call it the vertex form. And then you plug in the vertex. Vertex is a point, an XY point, but because it's special, we call it HK. So whatever the vertex is, you put it in the H and the K spot. You're given another point. That's just a plain old regular point, so we call that XY. You plug that in the X and Y spot. At the end of class, I'll zoom out so everybody can take a picture of everything together. Okay? So after you plug in, and this is 4 numbers that you plug in, X, Y, X, Y, you do the math to solve for A. You can see from the planets how important A is. Changes the height, the width of the parabola. So A must be known. So we do this work just to find A. That's kind of like part 1. That's it. It's 6 steps. It's a lot. It's a lot. So after you do step 1 through 4, find A, you're going to go back to step 1. In step 1, you're going to plug in H and K, the vertex, in the A that you just found. Okay? If you make it to step 5 on your assignment, 9 and 10, you're doing great. Like, so good. The last step is to FOIL and rewrite it in standard form, and that finishes it. But getting to step 5 is going to be a great accomplishment. Once you're done writing your steps, if you're feeling really confident, you can go ahead and try it. If you're not, I'm going to give everybody a little bit more time, and then I'm going to do it for you. So where it says try it, this is all the information you'll be provided. You'll be provided the vertex, which goes in the HK spot. You have to know that. And then one other point, and that goes in the XY spot. So this is it. You're trying it with this information here. thumbs up if you're on the try it. Okay, let's see hand if you want me to not move further right now. So far in the try it, I wrote step 1 here. In step 2, I plugged in the H and the K from the vertex provided. Now I'm going to hit step 3, which is to plug in the X and the Y provided. So now you plugged in 4 different values. And now you can do the math to solve for A. Now, in the graphing with the table, the calculator was super helpful and efficient. That's not the case here. Here, you're going to go a little bit quicker doing it by hand. You can still use the calculator, but the calculator won't do it all for you the way it did in the graph. So I'm going to jam dodge this. I'm going to do my order of operations. And I'll do these grouping symbols first. And then the exponent. Now I'm doing my algebra. It's a minus 6, so I'm going to add 6 to both sides. And it's a 4a, so I'll divide by 4. I got 1. Did anybody else work ahead and get a 1 for A? Okay, you guys. So this is a huge achievement. We figured out the parabola that goes through these 2 points has an A value of 1. That's like the most basic A value there is, but we're just starting out, right? So that is steps 1 through 4. Alright, so now I'm going to go to step 5, which means you go right back to step 1 and you plug in again. This time you plug in A, H, and K. So like I said, if you make it to step 5 on your 2 problems over the weekend, you're doing awesome. Step 6 is to rewrite this. You got to FOIL it. Put it out side by side and rewrite it. And there is an example in your book. I am going to finish it right now if you want to hang tight. Also, if you want to stop and take a picture right now, you can. Or if you want to wait like 1 more minute, I'll be done with the problem. Did anybody finish it? You all right? Nice, you all right? Now I want to be completely honest with you. In your 2 problems for homework, there's fractions. It's complicated. Do as much as you can. Use the book. Don't quit coming out to school and do it. I'll be here.